Yes,
Yes, sir.
sir.
Hello, am I audible? Actually, type into the chat box if you are audible. Okay, okay, fine, thank you. So, we have already covered the SCR. So, SCR is a semi controlled device. Then, we have seen its characteristics, commutation, firing methods, how to connect them in parallel series. Further, we have also seen some other power electronic devices. Now, we'll see application of this SCR. So, SCRs are used basically in AC to DC converters, that is rectifiers. We also call them rectifier. So, AC to DC conversion, why we need to use this AC to DC conversion? Because we know there are loads which requires DC supply. So those that DC supply cannot be supplied through batteries efficiently. I'm telling you. Just wait for some time. There is some disturbance. So there are batteries which can be used for DC loads. But the problem with batteries is they need recharging. So either you recharge them using power supply. Obviously, in that case, the grid is AC, so you have to convert it into DC and then you can charge the battery. Then battery can be used. Obviously, this is inefficient method because we are converting AC into DC and then storing it into battery, and again battery is going to give you the power. So in between, this battery is, you can say, is there, which is power consuming device, or the energy of this overall system is less. But where there is a loads which are in motion, in that case you can't provide the AC supply. So loads in motion, that means electric vehicles, suppose, or trolley cars. So in that case you have to use battery. So there is no option. But I'm talking about the loads which are there in our house or maybe in industries which needs the DC. So we can avoid the battery in this case and we can provide the DC supply. So no doubt the same circuit can be used for battery charging also, and then the same circuit can be used to drive the DC loads also. One more limitation in DC supply using batteries, generally the batteries are low voltage, we can say low voltage power supply. So for right from 1.2 volts up to at the max 110 volts the batteries are available. Mostly even the 110 is not available. Mostly up to 48 volts people are using batteries. So battery is nothing but the series parallel combination of cells. So individual cell is of 1.5 volts suppose. Then when we connect them in series, the total becomes 3 volts. Okay, if we connect two batteries of 1.5 volts in series, that becomes 3 volts. But their current capacity doesn't change. As they are in series, the voltage is getting double, but the current range remains the same. If you want to increase the current range to double, then you connect one more series combination in parallel with this. So now there are four batteries, four cells. Out of them, two are connected in series and another two are connected in series, and then these two series combinations are connected in parallel. So in that way, we can make the current capacity double. So there is a limitation. There is a limitation. So if you want more power, more higher voltages, in that case, you have to use AC to DC conversion. Then one may say that okay, there is another option available. We can use DC generators. No doubt we can use DC generators to get whatever voltage, DC voltage we want. So this is the same case as Edison have developed the DC system. It is the same case. So he was having set of generators. Now the problem with generator is it needs a prime mover. So a prime mover to the generator could be a diesel engine, petrol engine, steam engine, hydro, you can say turbines, steam turbines, pneumatic turbines. So think about the system configuration now. So for the prime mover you need lots of elements. It is a bulky system. Again, when there is no AC available and you want to go for high power DC generation, in that case obviously there is no option. You can go for this. Okay, have a diesel generator. That means diesel engine coupled to a DC generator. So you can have this combination. But where there is, you can say industry setup, household applications, in all of that battery charging applications, you can go for AC to DC converter circuits. So you have already studied one of the AC to DC converter circuit. It is diode rectifier. So you have studied diode rectifier. But the problem with diode rectifier is it is uncontrolled. It is uncontrolled. So let me share you now that okay, now let me share you that when we want a variable voltage in output, okay, what we want, we have a fixed okay, instead of this I'll type it. So what I want to convert is, I want to convert a fix AC voltage into a variable. Okay, what I want a variable DC voltage from a fixed AC. So this is the demand requirement. So options are, you can go for diode rectifier. So I'm just drawing it like a box. Okay, whatever, this is a half wave rectifier or full wave rectifier or whatever, but this is a rectifier made with diodes. Then there is a load here. So there is a load here and there is a AC supply. So let's say this is a AC supply side. So obviously this is a fixed AC to fixed DC, isn't it? This is fixed AC to fixed DC. AC side and DC side. Now to have a variable DC, I can connect. So I'll explore the options now. So what I can do, I can use a voltage divider. On this side there is no change. This is one option. Then I can use a auto transformer at the input. That means I am varying the AC itself to vary the DC. Such systems can be used. Obviously people were using these types of configurations when there was no SCR. So there was a need of developing something which is very efficient, not so much bulky, and still we can get the variable DC. So in the first combination here it is AC to DC, but it is fixed AC to fixed DC because there is just diode rectifier connected. Maybe filter and other things are connected. In the second circuit, we use voltage divider or potential divider. What is the drawback of this system? Obviously, there is a resistance connected. then the whole output of the rectifier is dropping across the divider network, and then from the variable terminal we are getting the output. So think about the power loss in that potential divider. So there is a continuous power loss in that potential divider, so this is not efficient. Then the if current rating is very high, then the potential divider will drop more and more voltage. Okay, there is a heat loss in that resistance. So again, not much practical. Another option is this one, auto transformers, using auto transformer. In this case, the AC itself is varied. So if we supply less AC voltage in input, we get the less DC in the output. But the problem here is, again, the auto transformer is a bulky device because it is electromechanical device. Another problem, extra cost is involved, size will be, you can say, more larger. Then there may be cooling arrangements and all those things to be used. Okay, just wait for some time, I'll bring my charger.